right, in our first video, we're gonna look at transforming a quadratic function. It says, how are the transformations of the graph f of x equals x squared related to an equation representing another quadratic function? So in part A, we have g of x equals negative 1/2 parentheses x plus 2 close parentheses squared. Thus is this g function down here. We can see here's f of x equals x squared, just the parent function. Let's take some notes somewhere off on the side just to talk about vertex form for a second. Remember, vertex form is f of x equals a parentheses x minus h squared plus k. The a value is going to tell us if the parabola opens up or down. Oops. So determines if parabola opens up or down. And it's also going to tell us whether it is stretched or compressed. All right, your k value, which we find, your h value in here with the x, what does the h value tell us? So the h value is going to determine the horizontal translation. We will remember these are the tricky ones. These are tricky x. It's always the opposite direction of the sign. And then our k value off on the end is going to determine the vertical translation. Okay, now that we have that sorted out, let's go ahead and look at our first example where we have g of x equals negative 1/2 x plus 2 squared. So our a value is that negative 1/2. Now when that a value is negative 1/2, the negative tells us that our parabola will open down. That's a reflection across the x-axis, so we can see it's opening down. And then the 1/2 tells us if it's a stretch or compression. If your a value is between 0 and 1, if the absolute value of it is between 0 and 1, it will be a compression. So this one is a compression. What that looks like is it looks like it makes our graph wider. Our b, or not our b value, what else do we have? We have our h value. So our h is equal to, it looks like a positive 2, but really it's a negative 2. That means that we shifted to the left 2 units. And then our k value, if there's nothing on the end, you can imagine there being a plus 0. Our k value is 0, which means there was no vertical shifting up or down. So if we look at our graph, we can see that we had a negative, so we opened down, we shifted to the left 2, and then we did not shift up or down at all. Now, if this a value is a negative 1/2, let me show you how that relates to the 1, 3, 5 pattern that we talked about last chapter. So parabolas have a 1, 3, 5 pattern. If your a value is something other than 1, then what we do is we multiply our 1, 3, 5 by our a value. I'm going to do that negative 0.5 as a negative 0.5 times 1, negative 0.5 times not 2, that should be a 3, and then negative 0.5 times 5. So our pattern now is a negative 0.5, a negative 1.5, and a negative 2.5. And you can think of those as being over 1. And let me show you how that shows up on the graph. So if I zoom in a little bit, from our vertex of our graph, so our vertex is, we shifted to the left 2 and up and down 0. I can get our next point by going down a half and to the right one. So if I go down a half to the right one, you can see I'm right on the parabola again, right there. Now I can go down 1.5, down 1.5 to the right one, and we're on the parabola. And then you can go down 2.5 to the right one, and you're on the parabola. So that's how you can get your 1, 3, 5 points on your parabolas when your a value is a different value. Okay, we've been talking for a while. Let's wrap this up. We've got our b over here. Part B, let's talk about our a value is a 2. That means that it's opening up and it has a stretch. Any a value bigger than 2 is going to have a stretch. It's going to look more narrow. Our h is a positive 1. Remember, h is in here, opposite sign of what you see, the tricky x. And our k, so that means we shifted to the right one. And our k value is a -3, which means we shifted down 3. So from the original function, if I zoom in a little bit so we can look at this one, we can see that we shifted to the right one and down 3, and we got our parabola, our vertex of our parabola at 1, -3. There's that h and k value. Now, if your a value is 2, let's do the 1, 3, 5 pattern, like I showed you in the last example. You take 2 times 1, 2 times 3, and 2 times 5. So you have a 2, 6, 10 pattern this time. Think of those as being over 1. From your vertex, you can go up 2 into the right one, and we're on the parabola. You can go up 6 to the right one, we're on the parabola. That's how you can get other points on your parabola.